The great news of Revit 2019 is a much deeper control in the steel fabrication. We have now the possibility to detail in a sharper way cuts, miters, welds, plates, and so on. Last but not least, we have a parametric connection library where we can copy and paste the most common solution to join different structural elements. The author decided that drawing an I-girder steel continuous bridge is an interesting way to put in practice these new features. So let's get started. This is our continuous steel bridge, and we will analyze this second span. We consider this as start, first span, second span, and third span. This second span we have divided in 4 sections, and we will analyze the first section of the second span. So this is like our bridge, and this is the steel fabrication of the bridge. We will assume that the things that we are doing now, they have been done in a welding shop, and some of these here in the sites, probably somewhere here. So this is a closer view of what we will do today. So today we will use this steel tab and understand plate as a structural element, what we can do with that. So we will do this and this element, and we will copy this part 3 times. We can now close probably this. Now we will enter in the live part of our video. We will work with plates and in the next video with welds on this beam as if it were in a welding shop. Now I will show you that another part is hidden. The superior plate is hidden in order to work better in a more comfortable way, let's say it. And these are all plates, because in order to show you the component in the next video of welding, we need to use all plates. I cannot do a family and then showing you how welding is working. So this is the idea, really mimicking what's welding shop with plates and parts and then bolts and everything that is more craftsman production of our girders. So we will mimic the whole process. Now I will show you in the longitudinal section that I have divided it into 1, 2, 3, 4, 5, 6 section and reference planes. Actually the section are 3 because those were the one I needed, and the reference planes are 6 instead. We will take care now of this number 2 section transversal, and we will then draw what it is now here ready. It's a transversal plate, a stiffener, and we will give 200 and 1495 as measurements, plus we will set in this modifier corner cut. You can see it here. We have a corner cut and it is roughly 30 millimeter. Then we can get started, and we take this 3D welding as a reference drawing. So here we need to go back on our steel tab and set as cross section our second cross section. So now it's done. We want to visualize it. We can see now that when we click on show, this is our plane. It is an endless plane. We have 2 colors. Before and a bit darker after, because this is not totally transparent plane, and this helps us to understand where we will draw our plane. Fantastic. We can start. So plate, we click on it and we are in the reference plane. We can take this endpoint, so interesting to see there is no any chunk there, so the reference plane automatically generates a snap where the intersection with the solid happens. And this is very powerful for us because it helps us to avoid lots of problem. I can adjust the width of it directly here as 200, then 1495 as height, and this is good, and I can click the finish edit mode. Then I model this way because I want to have the third dimension has thickness, and so parametric here I need to have 15 here. What I need to tell you, it's the first two measurements are, I would say, the x-axis and the y, and the z is what is thickness here. So depending how you draw, you could have also another one, but what I suggest to you, it's always drawing the x and y and leaving the thickness as parametric element, parametric number. So now I feel I need to adjust something here. Yep, you can see that this is not aligned, so we take this align AL and we align the profile. Good. Now we can see it. It's good. Then still again corner cut. We need to select our element. I want to the other side, and here it's important, before I've selected this side of the plate, and if you want the chop, yeah, so the component chamfer here, you need to click on this side of the element. Now I want this to be 30 in order then the weld to run through it easily, and 30 again. Apply. Okay, same thing in here, corner. Now I won't miss it, and 30 and 30. So it's a kind of volume that excavates. It's a kind of Boolean subtraction, and it is all you need to know about that. Then here I'm done. I can select it and mirror. Mirrored, beautiful. And another thing we can see in 3D welding here. Oh, fantastic. Then I will copy it. I want now to underline here and to draw another plate. I have a longitudinal reference plane which runs parallel to my plate, and I will use it. Yeah, so now you see that intersects here. I will draw now my plate, and I will adjust in another section. So still again plate. This is a connection plate. and I will use to connect the two. Here I want 600, and here I want to have 100. I will use it to connect the two beams. Now in my section longitudinal, I have set to a more specific view. It's a call out, and I will use it in order to divide my element how it's needed. So now it's divided vertically, and I will then divide it horizontally. So again, here, correct. Okay, so this is the part of the first span here, and this is the second span, and we can check it now again here, and now we can take it back, these two parts, unhide the elements and go back. The remaining job is just to copy them. It's kind of boring. I will take it. And in the next video we will see how to weld different elements and how to tag different elements. See you in the next